Consider a coordinate system on Earth's surface where toward the sky is the positive j-hat direction. When gravity pulls on an object, in which direction is the pull on the object? The negative I-hat, positive I-hat, negative j-hat, or positive j-hat? Go ahead and give your answers for A through E. Now I'll give my answers. When the object is rising toward the sky, what is the direction of the pull that Earth exerts on that object? Well, gravity is an attractive force. It can't push, only pull. And since the Earth is below the object at this time, Earth pulls in the negative j-hat direction. What about when the object is at the peak of its trajectory? Let's say this is the path that the object takes. Which way does Earth pull at the peak? Well, Earth pulls down, always. What about when the object is falling back toward Earth? What's the direction of the pull then? Negative j-hat. What about if the person holds the object in their hand? Then the direction of the pull of gravity is negative j-hat. The direction that gravity always pulls on an object near Earth's surface is negative j-hat. It pulls down always. So we don't want to confuse a pull with velocity. The velocity can be a wide range of different things, but the pull is always constant. So we want to separate those two ideas in our mind. And the pull is what we'll call in the future a force. Now imagine a ball is rolling along a platform with some velocity, and at the same instant that the ball rolls off the platform's edge, an identical second ball is released from rest. We want to draw motion maps for these spheres in two dimensions. The one's initially moving and the other is initially at rest. Go ahead and draw for yourself on scrap paper what you think the motion maps would look like in two dimensions. And how do you think the times of flight for these balls will compare? Okay, so the correct motion map for this situation is on the next page. The balls actually will hit ground at the exact same time, and I have several videos which I'll post to provide evidence for that. The idea is that the x and y dimensions are independent. Earth pulls down, and that's what causes both of these objects to move down. Since they're identical objects and Earth pulls on them equally, they will definitely hit ground at the same time, no matter what their horizontal velocities. Notice a couple of important things here. If you look at the horizontal velocity that the object had initially, notice that that horizontal velocity remains constant throughout time and never changes throughout the entire flight of the ball. Whereas the vertical component of its velocity is changing. The reason for this is Earth is causing the object to accelerate in the y dimension, but not in the x dimension. And that's really critical to two-dimensional motion problems.